Hi, welcome back to Mat140. Today we're going to talk about annuities. And we're going to split this up into two parts. One, the first part, we're going to talk about part one here, part A. And this part, what we're going to do is we're going to talk about how much money you're going to have back if you make a certain amount of payments. And then the second part is going to be trying to determine how much money you want to make, how much are you going to make for your payment. So let's talk about an annuity. What is an annuity? Annuity is a kind of a savings account. You're going to put your money is compounded. It's a plan, but we're going to make the same amount of payment. You can make it monthly or yearly or whatever. Usually you make it monthly. So we put the same amount of money into this annuity every month. And then after a period of time, maybe 10 years, 15, 20, we're going to see how much money we have back. In 8.2, we did something like this again. But what we were doing in 8.2 is we were putting a lump sum and then seeing how much money we got back. This is a little different because we're putting in the same amount each month. We're not putting in a big amount, like $10,000 into our account and just letting it sit there. Every month we're depositing the same amount of money into this account, and we're going to see how much it grows to. So it's a little bit different from what we were doing. And of course, the formula is slightly different. The future value of an annuity is the value we have. We would call this A. It's the amount that we have when the time is up, 20 years. And that's going to be our future value. And of course, they can kind of predict if there's a certain percentage, like interest rate of 3%, they can predict at the end of 20 years, if you put $80 every month into an account, how much of your money you're going to have. And that would be your future value. You put $80 in for 30 years, maybe you have $20,000 coming to you or something like this at the end of that period of time. And so that's how it's a little different from, we're not putting a big lump sum, we're putting the same amount each month into this plan. Then today we're going to figure out how much money you would have coming back to you. So the formula we're going to use is kind of a complicated little formula, unfortunately. A is your future value. This is how much you're going to get back. And R is how much money you're going to deposit each month. That's the amount that you're putting in each month, $80, $60, whatever it is. And we're going to multiply this by a rather complicated thing. You have a parentheses and another parentheses. This is going to be 1 plus, your rate of interest, we'll use a small r, over how much, over the months that you put in a year, or how many times you deposit this money during a period of years, which is usually like every month, so it would be 12. Okay? And then it's going to be raised to a power, and the power is the number of years, n equals the number of years times the number of months that you put this money in for. The years times the months. And then we're going to subtract 1 from that. That kind of converts it back to a decimal. And then when we're done, we're going to divide this whole mess by R divided by M again. So you can see the formula is a little bit harder than what we were using. It's similar to what we were using. Remember this part and this, but we didn't have all this junk. So we're going to see what happens here. So there's an interesting problem in the book. And I'm modifying this problem. Let's see if I can find my modification. Can't quite find it. See if I have it over Yeah, that's pretty much it. Okay, so according to this problem, you go to Starbucks every day, 6 days a week. So you're going to Starbucks and you're buying a latte, and I'm going to change it a little bit. It costs you $3.95. I see kids walking every day with a latte, and they're doing this for 6 days a week. Sunday they don't get one. Probably get something different. But 6 days a week they get this latte. It costs about $3.95. I think that's a fair price. I don't know what these run. I don't really go to Starbucks. But anyhow, and so we're going to try to figure out how much you could save over a period of years. Let's see, they said 15 years, if you just continued this trend, how much money could you accumulate if you didn't buy this Starbucks? Instead, you made a pot of coffee at home and you just drink it. How much money could you accumulate over 15 years? And that's what A is. Well, the amount that you're going to get is A, and that's the future value. The future value of not buying this and instead putting it into a savings account. Now, you couldn't put $3.95 into an account every day, so you're spending $3.95 6 days a week, and there's usually 4 weeks in a month, right? So on an average, each month you're spending, and of course you're going to need a scientific calculator, which that you're going to be spending $3.95. Let me turn this on first. $3.95. You're going to be saving this money. $3.95 times 6 days a week times 4 weeks in a month. So every month, believe it or not, you're spending $94.80 on this drink. That's how much you're spending. So now we're going to try to put it into account for 15 years at 3%. We're going to put it in at a 3% account. So first thing we're going to do is put in the amount of money. Every month you're depositing $94.80. Okay. Now we're going to figure out what R over M is because it comes up quite a bit. R is 3%, but we're going to change that to a decimal, so that'd be 0.03. And M is the number of months in a year, 12. So we're going to divide that off and see what we get on our calculator. 0.03 divided by 12 is 0.0025. Now, it's very important when you write this down that you're careful. Don't write 0.025. Went through that pretty fast. Don't write 0.000. Be careful about this amount. So that's what R over M is. Okay, so we're going to put into this program, we're going to put 1 plus 0.0025. We already divided that out. See, save time if you do this first. Now, N is the number of times it's compounded. So that's the number of years, 15, times the number of months in a year, 12. So 15 times 12, 180. So that's the power we're raising it to. Not 15, but 15 times 12. That's what N is. Going to subtract 1. Then when we get done with that part, then we're going to divide it by R over M, which is 0.0025 again. So let's calculate. First thing I'm going to do is actually work inside the parentheses. I'm going to solve this parentheses first. So you can, in your head, configure what 1.025 is. It's going to be 1.0025 That's what it's going to be. When you add that together, it's just putting a 1 in front of there. We're going to raise that. Going to hit that raise key to 180. We're going to hit equal, but keep it in your calculator. Don't write it down. That's what we have when we did this parentheses. Now we're going to subtract 1. That's a new number we have. So we did this, we raised it to the power, we subtracted 1. Now we're going to divide it by, hit divide, 0.0025. See, I'm just leaving all this in, and then I'm going to hit my equal sign. That's what I have when I did this whole parentheses. Now I'm going to multiply that by how much you're putting in the bank every month, times, hit my times sign, 94.80. So at the end of this period of time, you should have 21,517.01 coming back to you. So that's how much you would have if you saved, if you didn't buy this latte every day, and you did that for 15 years consecutively. So putting about $100 in the bank, 15 years, you get $21,000, $100 each month. What's $100 each month? $1,200 you put in. If you put 1,200, always put $95. So let's make it 95 times 12 times 15. If you just put it away in a cooking jar, you would have 17,000. But by compounding it, you get 21,000. So you get a little bit more money. So that's how an annuity works. Let's try another problem. Let me get another sheet of paper. Let me copy down my formula, though. You should always start with your formula. Capital R is the payment. Remember, 1 plus R over M to the nth minus 1 over, so it's in one big parentheses, R over M. So we're going to try one of the problems out of the assignment. I'm going to try problem number 7. This is on page 423. Okay, so it says you want to figure out what you're looking for is the amount. You're putting $200 into this account. So that's what R is, the $200. Your monthly percent is 3%. That's little r is 3%. You're doing this monthly, so M is 12. And you're doing for 8 years. Y is 8. Okay. So let's take some of this stuff and figure out something. First, we want our R over M. So what is that? That's 0.03 over 12. I think we just did that, but let's try it again. Make sure we didn't make any mistakes. This is very important that you change the 3% to a decimal. You divide it, and this number must, because that's usually where most students make their mistake. They write it as 0.25 or weird stuff. Okay, next we want to find N. N equals the number of years times the number of months. 8 years, 12 months in a year, 96. That's what N is going to be. So now we can fill in our formula. I'll put it down here. A equals R, 200. Nice number, huh? Okay, 1 plus 0.0025. In the parentheses, raised to the 96th power, minus 1, all over 0.0025 again. See, those numbers match up. So let's see what we get. I'm going to put my 200 down. I'm going to work in the parentheses. I'm going to start with this parentheses here. 1.0025 raised to, put it over here so you can see, raised to the 96. So I added these together, which was pretty easy to do. Raise it to the 96, keep it. Don't hit it, don't hit enter, don't do anything, just leave it. If you did hit enter, if you did hit the enter, it'll still work. But okay, then -1. See, we've done this. Now we're going to do this. -1 equals. Okay, I probably should hit the equal. Okay, then hit divide 0.0025 equals. So that's what we got when we did the whole parentheses. I'm going to write it down just to see what it was. But I'm keeping it still on my calculator. Then I'm going to hit equal. Oh, no, I'm not going to hit equal. I'm going to hit times, because I already got an equal, times 200. And there's my number. $21,669. And I'm going to round it up 47. We're round up a penny, 48 cents. Put a dollar sign there. So at the end of 8 years, if you put $200 a month into, you should have this up. We can also use this for figuring out a car payment. If you were paying $200 a month for a period of 8 years, this is how much money, how much car you could buy for your money, $21,600, because your payments are compounded. The reason they compound your payments is because the bank can get their money first. So you're paying off a lot of interest in the beginning. That's why you don't have too much equity in your car after 1 year, because almost all your payment went towards the interest and not towards your actual payment. We'll get into that a little bit later, but this will give you kind of an idea. So R was 200, R divided by M, but you have to change R to a decimal, and then the years times the months. Okay, so I hope this helps. Next time we'll be doing something a little differently.